Hello, algebra students. We're looking at indicator 13 today, and this involves solving systems of equations. So we have here in number 1, for example, two equations. That is a system. And the solution to the system is the ordered pair, that is, it's an x and a y value, that satisfies both equations. So the way we're going to solve these today is we're going to graph both of those equations, and each one will be a line, and where those lines cross, that is a point that is on both lines, right? Remember, the line, for example, that we get to graph that's just a graphical representation of all the ordered pairs that make up that line. And when we graph the other line, that's a graphical representation of all the ordered pairs that make up that line. So where they cross, that's an ordered pair that's on both lines. That's an ordered pair that satisfies both equations. So let's do this. These are in slope-intercept form, which helps, makes it a little easier to graph them. So we need the slope and the intercept for each of them, and then we'll graph it. So looking at the first one, the slope is 1. The y-intercept is -4. So we go to the y-intercept to get 1 point, and then we use the slope is 1, so the rise over the run is 1, right? I'll write that over here as well. Rise over the run equals 1 over 1, since the slope is 1. So if we go up 1, like that, and then over 1, like that, we get to right there. That's another point. We try to graph these as accurately as we can. Obviously, the getting the right solution depends on graphing it really well. And I'm not going to try to be perfect, although it looks like I'm trying to be perfect. But the better we can get it, the better it'll turn out. So go about like that. Then I'll switch colors because I can, and it's fun. Let's see. Let's go with something like that. A little bit darker. And the other line, the slope is -5. The y-intercept is +2. So the rise over the run for this one is 2 over 1. So slope y-intercept of 2 gives us 1 point. Oh, I wrote the slope down wrong. Sorry about that. Go back and erase that. Oh, that's not right. We'll get it. Need to make that smaller. Okay, finally got that. Rise over run is -5 over 1. Okay. So intercept is 2. Slope is -5/1. So we go down 5. 1, 2, 3, 4, 5. And to the right 1. And that's nice. It came right on top of one of the other points that we used. And so that kind of gives away the solution already, right? So we have our 2 points, and we will go ahead and graph that. If we had not been so lucky to get that point kind of showing us the solution already, we would have to look for where these cross, which is what we look for anyway. There it is. So we have to then write down our solution as what is that point, okay? So we've done most of the hard work, but we have to look at that, and it's 1, -3. So that's the solution. The ordered pair (1, -3). Okay? So let's do a couple more of these. This next one is also in slope-intercept form. So look at the first line. The slope is 1. Okay, that's what's multiplied by x, right? 1. The y-intercept is also 1. Okay, so we know the rise over run is 1. I won't write that down this time. The other one, the slope is also 1. And the intercept this time is -1. Okay, so let's graph that first one. Y-intercept of 1, slope of 1 as well. Right, there's the slope, and that's, so rise over run is 1, so we go up 1 over 1. We've got a couple points, we can graph it. Okay, and then we look at the other one. Let's see, I didn't write this intercept down correctly. Should have said intercept equals -1. Okay, so intercept is -1. So we have that. And then slope is +1. So rise of 1 and run of 1, like that. Gets us to right there. And we draw that line. And you guys can tell these look like they're parallel. Parallel lines are never going to cross, right? Okay, boy, that's bad. I almost do not want to leave it that bad. Hard to draw these well. It's a little bit better. So yeah, they're not going to cross. So what does that mean? What's that mean for our answer if they don't cross at all? We're looking for the intersection. The intersection is our solution. So, no intersection, I guess, means no solution, which you can write this way, just with the words no solution, or you can write that symbol, meaning the solution set is the empty set, no solution. You can write it either way. Now, you may have noticed there was a clue right off. After we get this done, we can see it, and maybe you saw it before. The slope is the same, right? We had a slope of 1 for each of those. So that means they're parallel, okay, and they're not going to cross. So let's look at a couple more of these. So here we have a couple more that are also in slope-intercept form. They're kind of, we're getting spoiled here. We're not having to convert any of these to slope-intercept form yet. So let's do this one. So the first one, the slope is 1/2. And the y-intercept is -4. Okay, so let's just go ahead and draw that line. So we go to the y-intercept. And now the slope is rise over run for this one is 1/2. Okay, so a rise of 1, a run of 2 gets us to there, right? There we are. We draw the line, and that's one of our lines. Okay. So the other one, slope is -3/4. Intercept is 1. Rise over run on this one is -3/4. So let's look at that. Intercept +1 is right there. That's 1 point. Use the slope to get another point. Rise of -3 means down 3 like that. Oh, that's pretty sloppy. Try that again. Down 3, 1, 2, 3. Run of 4 gets us over to there. Okay. Right there. It looks like that's probably going to be our point of intersection also, right? So we have our 2 points. Negative slopes are especially hard for me to draw. Boy, yeah, that's straight at least. Try one more time. Okay, better. And, of course, we can't draw them perfectly, but I'm going to say the solution is 4, -2. Now, we haven't checked any of these. So, this one might be a pretty good one to check. And it's good practice to check these anyway. I'm going to take a quick look at the line first of all. First one had a slope of 1/2. Second one had a slope of -3/4. Okay. So yeah, let's run through this and check it. So if we plug those two numbers, first of all, let's write down our solution here. We got 4, -2, right? So we said that should satisfy both equations. So let's plug it in, and we should get true statements for both. So we put in the 4 for the y in the first one. We get 4 equals 1/2 times x, which is -2 minus 4. So 4 equals, oh, I did this backwards. Didn't look like it was going to work, and of course it's not going to work. I'm going to put it in backwards. Okay. -2 goes in for y. Let's put that down there so I won't mess it up. Y is -2, x is 4. So we put -2 equals 1/2 times 4 minus 4. Okay. -2 equals 1/2 of 4 is 2 minus 4. Yeah, -2 equals -2. That's true. But we don't know if we're correct yet, right? We just checked this in one of the equations. We need our point, our ordered pair, to satisfy both equations. Okay, so to really check it, we've got to put it in the other one as well. So let's do that. We put in y of -2 equals -3/4. Now we're doing this one, right? Or I should circle the whole equation if I'm going to circle something. That one. So -2 equals -3/4 times x, which is 4. Okay, and then plus 1. So we get -2 equals, the 4's cancel, -3 plus 1. Marvelous. -2 equals -2. So that is also true. So when we plugged it in to the first equation, we found out it does satisfy that equation. It makes it true. Same point, right? The same point. That one right there. We put it into the second equation and also got a true statement. It makes that one true as well. So it is a solution. Okay. And we don't need the xy's there. I just did that to make sure I wouldn't make a mistake. Okay, so one more. And we probably won't check this last one either. It's really a good idea to check these. It gives you practice. And if you make a mistake like I did, that's good too, because you learn from your mistakes, right? Okay, so this last one, these are not in slope-intercept form. So the first thing we want to do is put them in slope-intercept form. So work on the first one. I'll do it right up here. X minus 3y equals -6. We're going to subtract x from both sides, right? And so we get -3y equals -x minus 6. Divide both sides now by -3. And that means divide each term, of course, by -3. And so we get y equals, and negative divided by a negative is positive. Positive x over 3, which we're going to write as 1/3 x. Actually, I'll go ahead and first write it like that. Okay, x over 3. Then we have a negative over negative, so that's plus 2. So now we will rewrite it 1/3 x plus 2. Okay? So that's the first one. Now let's do the other equation, which is x plus y equals -2. We Need to get y by itself. So subtract x from both sides. Gives us y equals negative x minus 2. And then that one's done. So now we have both of them in slope-intercept form. And we can now graph them both. I didn't leave myself a lot of room. I'm going to write those up here in slope-intercept form. I'm just transferring this up here. Y equals 1/3 x plus 2. And the other one, y equals negative x minus 2. So the first one, going with the blue, I won't write the slope and intercept separately this time. We'll just look at it, right? And we can pick it up right from the equation itself. The intercept is positive 2. To get another point, we'll use the slope, which is 1/3. And so rise of 1, run of 3 gets us to right there. We've got our 2 points. We make our line. Okay. So the other one, looking at the equation again, the y-intercept, negative 2. So we go to negative 2. The slope just shows us negative x. That's a negative 1, right? When it's just a negative sign, there's of course a 1 there that we don't write down. So negative 1 is the slope. So the rise of negative 1, run of positive 1 gets us to there. We've got that one. And now we have that line. And not drawn very well, but I think I got lucky and hit the point. And so, yeah, it looks like it's right there. That's our solution. So that is negative 3, 1. And since I talked about how much I really love to check these and what a good idea it is, I guess I better follow through on that. And let's check this one. Scroll down to give ourselves a little bit more room. And we got to check it in our original equation though, so I need to leave those on the screen. Don't check it in the slope-intercept form that you created that you converted it to, because you might have made a mistake converting it. So you really need to check it in the original equation. So we have the first equation, x minus 3y equals negative 6. We're going to plug for the x, we're going to plug in the negative 3, right? Negative 3 minus 3 times y, and the y is 1, equals negative 6. Negative 3 minus 3 equals negative 6. Great, it works. So that's true. Looking at the other equation, x plus y equals negative 2. The same point gets plugged in there, right? So negative 3 goes in for x. 1 goes in for y. Negative 3 plus 1. That's negative 2. Perfect. So it checks out. So that is solving them by graphing. Now there's one more thing I want to show you. I'm going to save this file. And then we're just going to bring up a blank page, and I'm going to show you some general things that are good to know. So the ones we've looked at we've had intersecting lines in most of them. And when you have intersecting lines, when you end up with lines that intersect, that corresponds to one solution. This is the most common situation. You can also have, as we saw, parallel lines. They do not intersect at all. And that means no solution. So another possibility that we did not do one like this yet is you've got a line and when you plot the other equation, when you graph the other equation, I don't like that line. Let's try again. When you graph the second one, it just turns out to go right on top of the first one. It turns out they're the same line. The equations may look different, but they really are the same line. And so sometimes they will give you a problem like that. So what's the deal then? If you have two equations and they really correspond to the same line, then, well, every point on that line actually satisfies both equations, right? And in that case, we just write that down as infinitely many solutions. Infinitely many solutions. It's not correct to say all real numbers in that case, because it's not that all real numbers can be put in for x and y. It's that any point on that line, right, will satisfy both, because both equations really are the same line. So it's a whole bunch of ordered pairs. Any ordered pair on the line works, and we just say infinitely many solutions. So that's the three possibilities, and that's enough examples for today. So that's all, and I will see you later.